Hello everyone, I am Dr. Jayanti, Professor, Department of ECE, Nanda College of Technology. I welcome you all to my YouTube lecture on mobile radio cellular radio communication. In my previous lecture, we have seen how your mobile is getting connected to another mobile and how your mobile it is connected to the landline network. And we have seen some few definitions about basic definitions in mobile communication and various channels available and how the channels that links your base station and mobile. And we had discussed about mobile switching center, and we have seen what is meant by transceivers. So in this lecture, we are going to see the basic principles of cellular system and cellular system architecture, what is cells and what is the meaning for clusters and frequency reuse concept, cell splitting, handoff strategies, cellular system concepts. So while coming to the definition of cellular mobile communication means it is not standard, it is mobile communication. Cellular that represents the region where the subscribers are present. So togetherly we are giving the name, it is cellular mobile communication. And it uses large number of low power wireless transmitter to create cells. It's again um, the particular subscribers available in the particular region that is split into cells. So in that particular cells, we are locating variable power levels, and that allows that cells to be sized according to the density of the subscribers. Again, here we are going to see the handoff strategies. How your mobile user, if your mobile user he's traveling from one cellular region to another cellular region, how the base station that shares the frequency in between cells, that we are going to see in our handoff strategy. Next one is the frequency reuse concept, because the radio frequency, it is limited, but the number of users and subscribers worldwide, it is vast. How effectively we can utilize this radio frequency in order to satisfy all the subscribers present in the world. So the mobile uses a separate temporary radio channels to talk to the cell sites. For each and every user, he'll be allotted with the two set of links, one for the forward link, user how he is getting connected to the base station, and from the base station he has to receive the signals, that is to the reverse link. So for each and every user, he or she is allotted with pair of frequencies for communication. So mobile communication principles show radio energy dissipates over distance. That is, your radio signals for how long it can dissipate your strength of the radio signal, how long it can dissipate without any distraction. So the mobile must stay near the base station, means you will get good quality signal. And if the mobile it is moving out of the base station, means you'll have some uh, weakness in the signals. So the basic structure of mobile network that includes telephone system and radio services, that we'll see. So mobile communication principles. Here we are having one mobile which is fixed in which is used by one user, and how it is getting connected to the base station. Base station means your base station that gives the signals to the user, means that is called as your forward link, and the signal it is shared from the user to the base station, means that is called reverse link. Again, this base station it is connected to the mobile control equipment, and that mobile equipment, if the receiver he is in the another station, mobile station, means he is linked to this base station. Both the stations are connected via the mobile switching unit. So if this is a link established between mobile to mobile, and if the user he is calling to the landline mobile, means that mobile switching center that is connected to the PSTN, that is public switch telephone network. From the network he will be connected to the user who is available in the landline. So that is a thing that we had already discussed in the previous slide, in the previous lecture. So the early mobile system. So the first of all, in the traditional mobile service, we'll fix some high-powered transmitting antenna, which can be broadcast over for 50 kilometers. So only one tower which transmits high power, like broadcasting from the tower. It is shared by all the users. The number of users in that time it was low, so that was okay that time. But the number of subscribers currently, they cannot utilize these kind of systems. Early mobile system, cellular concept structured the mobile telephone network in a different way. Many low power transmitters were placed throughout a coverage area. For one area, one high power transmitter, they will not fix for each and every transmitter. Low power transmitters were fixed in different area and dividing a metropolitan region into 100 different cells. For example, if you are taking Chennai means, it has different cellular regions. For each and every region, you will fix low power transmitters, and each and every low power transmitter that shares 12 channels each. Mobile systems using cells. Interference problems caused by mobile using the same channel in adjacent areas proved that all channels could not be reused in every cell. For example, we are having one cellular region, for example, Erode and Perundurai. If you are taking that region, means Erode and Perundurai, they are nearby. Uh, the users can move from the user, that is the number of channel radio frequency allotted to the Erode region, that can be get overlapped with the number of radio frequencies allotted to the Perundurai region. So if the because Erode and Perundurai are the near cellular regions. Okay, so which may cause interference problems. In order to avoid that, what they are doing, they are using the reuse concept, frequency reuse concept, and a different location. Okay, this affects the efficiency of the original concept. Frequency reuse was still viable solution in the problems of the mobile communication. Let us see how they are overcoming that problem. The cellular concept employs variable low power levels. Cells are sized according to the subscriber density and demand in a given area. So based upon the population and subscriber strength, they are splitting the cells. Cells can be added to accommodate population growth. If more number of population in the particular area means, your cellular regions can be further increased. Mobile system using cells. As with the early mobile radio system, the base station communicates with the mobiles via a channel. So as we said, mobile user has communicated with the base station in the particular area. The channels is made up of frequencies, one for transmitting to the base station and another for receiving the information from the base station. So two pairs of channels that is needed for communication between base station and the mobile user. So this shows the mobile system using cellular architecture. Cellular system architecture. An increase in demand and poor quality of existing service led to research into ways to improve the quality of service and support more users in the system. Frequency spectrum available for mobile cellular was limited. Therefore, efficient use of these frequencies was necessary. For example, if you are taking the radio frequency means it ranges from 850 megahertz to some tens of gigahertz that is utilized for mobile communication. Your RF range of 850 megahertz to some tens of gigahertz only, that throughout the world we are using for the mobile communication. So through the frequency reuse concept only, and the whatever the frequency utilized in the particular cell location, that can be reused in the another cell location. Let us see how and at what distance the frequency reuse it is possible. Cellular system architecture. In model cellular telephony, rural and urban regions are divided into areas according to the specific provision guidance. Why means your rural area, the population, the subscribers are less, and if you're taking the urban regions means the subscribers are more. So based upon the population, we have to split the cells. Deployment parameters such as amount of cell splitting, cell sizes are determined by engineers' experience in cellular system architecture. So the population, based upon the strength of the population, we are splitting the cells, and cell size is defined or designed according to the need of the subscribers. So now let us see what is a cell. Cell is a basic geographic unit of a cellular system. The cellular means how the cell it may be of hexagonal shape. So we can it looks like a honeycomb shape of the area which is coverage region is divided. Cells are base station transmitting over small geographic areas that are represented as hexagons. Normally the preferred size of the cell it is hexagonal, and size varies depending on the landscape. So clusters. The combination of cells that forms a cluster, we can call group of cells forms a cluster. So number of channels are reused within a cluster. So no channels are reused within a cluster. So cell 1, for example, some 850 megahertz to 950 megahertz that is utilized by cell 1 means this 850 to 950 megahertz frequency that cannot be used in cell 2, cell 3, cell 4, 5, 6, 7 and all. So the figure shows the 7-cell cluster concept. So now let us see how a frequency reuse is possible. Only a small number of radio channel frequencies were available for mobile system. As I said, radio frequency limitation, it is for mobile communication, it is 850 megahertz to tens of gigahertz. That throughout the world, it has to share the same frequency band. So the frequency reuse concept, it is a must. And let us see at what distance how we can reuse the concept. For example, the frequency utilized in India, the particular region, the same can be utilized in Gujarat or US. Frequency reuse concept is based on the assigning of each cell a group of radio channels used within a small geographic area. So cells are assigned a group of channels that is completely different from neighboring cells. The neighboring cells, they cannot utilize the same set of frequency. The coverage area of cell is called the footprint, and it is limited by a boundary so that the same group of channels can be used in cells that are far enough apart. Let us see the concept. This is the frequency reuse concept. Here we are seeing three clusters of or each cluster of each cluster with the size of cell seven cell size. So first cluster cell 1 and followed by 2, 3, 4, 5, 6, 7. Similarly another cluster. So totally we are seeing three clusters here. This is first cluster and this is second cluster and third cluster. For example, cell 1 frequency, if you are allotting 850 megahertz to 950 megahertz in the cellular region, we cannot utilize the same frequency in the nearby cells, but we can use the same frequency in the nearby cluster, 852 or 950 megahertz frequency that can be utilized in this cell, not here. Cell 1 and the center point means you can utilize the distance that should be a particular logic. It has to satisfy particular logic that I will explain again. Again, the same 852 or 950 megahertz frequency that can be utilized in this cluster also. So in this way, you can use your frequency reuse. Next one, cell splitting concept. Cell splitting. Normally, we are dividing this. We are forming the cell in hexagonal shape. Okay, and we cannot use as a uniform region size for each hexagon. So based upon needs, we are going for some cell splitting concept. Let us see how it is possible. So cell splitting. Normally, we are using this concept in urban centers to be split into as many areas as necessary for acceptance service levels in heavy traffic regions, while larger, less expensive cells can be used to cover remote rural regions. See, you can see the cellular region here. So within the cellular region, again you are subdividing the cell. This concept that you are calling, it is your cellular splitting. So instead of one tower within this region, again you are splitting the cell, means you are fixing one more base station. So this base station and the uh, coverage region of the your particular subscriber, he can utilize the radio frequency available in this particular part very effectively. Hand of strategy. Next one is your next concept we are going to see is our hand of strategy. For example, mobile, we are using a subscriber. He is in a mobile car, and he's having the he's having the pair of frequency which is allotted by the base station in a particular cellular location. Now the mobile user, he is moving from one cellular region to another cellular region. Again, the signal strength of this station to the same person, he is away. And if you are considering the base station of the second station, it is near to the signal strength that of the second station, that will be much more high. So without any disturbance, he has to what is that, without any block or any drop any drop in the signal, the frequency, it has to be handed off to the nearby base station. Let us see how it is done. The final obstacles in the development of the cellular network involved is the problems created when a mobile subscriber moved from one cellular region to the another during a call. So call must be either dropped or transferred from one radio channel to another when a user crosses the line between adjacent cells. Dropping the call is unacceptable. Therefore, handoff was developed. So handoff. So what is happening in the handoff? Handoff occurs when a mobile telephone network automatically transfer your call from a radio channel to a radio channel as a mobile crosses adjacent channels. During a call, two parties are on one voice channels. The system switches the call to a strongest frequency channel in a new site without interrupting the call or altering the user. So that strategy we are calling it as your handoff strategy. And the next concept, it is cellular system components that we are going to see here. Cellular system offers mobile and portable telephone station with the same service provider, fixed station over conventional wired loop. So for connecting the cellular system to your landline wired loop, how we are going to connect and what are the mechanism that is happening in the cellular system. So cellular components. So four major components that we have to remember. It is public switch telephone network. It is PSTN, and the mobile switching network. We can call it as mobile telephone switching office also, which connects PSTN network to all the base station, and cell side with the antenna system that we are calling it as our what is that, base station. And mobile subscriber unit. Mobile subscriber unit means the user. So PSTN and MTSO. PSTN, it is made up of local networks, the exchange area network and the long haul network. And MTSO, Center Office for Mobile Switching, houses the mobile switching center, field monitoring and relay stations for switching calls from cell sites or wireline center office. In the analog cellular network, the MSC controls the system operation and controls the calls, tracks billing information, and locates cellular subscribers. Cell site. Cell site is the base station. The term cell site is used to refer the physical location of the radio equipment that provides coverage within a cell. That means what we are saying, it is our base station. The list of hardware located at a cell site includes power sources, interface equipments, a radio frequency transmitter and receivers, and antenna systems. So these are the basic things for the base stations. And a mobile subscriber unit, which is our mobile phone. So consists of a control unit and a transceiver that transmits and receives a radio transmission to and from a cell site. That is our each and every mobile phone that has the capability of receiving and transmitting signals. That's what we are having. We are saying a transceiver, it is inbuilt within our cell. So three types available: mobile telephone, typically transmits power of 4 watts, and portable, typically transmit the power of zero point 0.6 watt, and transportable, typically transmit the power of 1.6 watt. Mobile subscriber units, that we are calling it as your handset. Mobile telephone is installed in boot of a car. Handset is installed in a convenient location to the driver. So through Bluetooth also we can operate our mobile phones, and the mobile can be used directly by the driver also. So portable and transportable telephones are handheld and car can be used anywhere. The use of portable and transportable telephone is limited to the charges life of the internal battery. So it says something about the battery, that is the lifetime of the battery. So with this thing, we are concluding today's session. Thank you one and all once again.